Here is a Hammond B-2 organ that we're getting ready to set up with a Leslie. I put all new capacitors in the B-2 electronics chassis. You can see there's a new filter capacitor there. These particular kind are really easy to mount in there. And we replaced all the old paper caps in there. Here's the Leslie module, which came from the B3 guys. And inside of here is an isolation transformer and some capacitors and resistors. And what this does is this allows DC voltage to be sent down the audio leads to the Leslie amplifier. When the DC comes in, it goes into a control tube which controls a relay to make the Leslie run either fast or slow speed. And then there's some capacitors in the Leslie amp which block the DC then from getting into the rest of the amp circuits. The isolation transformer is needed because the primary side of this circuit, it comes out of a transformer. This is the output transformer in the Hammond, but the transformer center tap is grounded. So in order to isolate the DC circuit, control circuit from ground, this isolation transformer here is used. High voltage is provided into the Leslie system through this yellow wire here. Actually, I'm sorry, through the brown wire here, which connects to the rectifier cathode of the 6X5. Now there is an adapter supplied to be able to use it with a 6X4 like would be in a B3, but here I just went ahead and wired it right into the power supply. Just drilled a little hole there to hook it up. And then the yellow lead is the ground lead. Red and black are the audio from the Hammond output transformer. And then this brown cord here goes to the Leslie fast or slow switch. Down here is the Hammond power junction box. This has originally been used with a Hammond tone cabinet. It's got a 5-pin connector on it. And so I'm going to upgrade to a new 6-pin connector for the Leslie hookup. Also, we've got a new Leslie switch here, and we'll just have to wire this up. Here's the actual switch mechanism and the decorative faceplate and junction box that mounts on here. So I've almost got the B2 ready. I'm going to put the new 6-pin connector on and get the switch set up. Here's a Leslie, and this is South JK's Leslie. The organ is actually one that's going to be going to a church, the B2, and the church has their own Leslie. But I thought, well, we ought to get this Leslie rebuilt while we're working on this kind of thing, and we use this as a test setup on the B2, and eventually that Leslie is designed to work with this M143 here. Need to do all new capacitors and new wiring in the M143 though. We'll start with the Leslie. And this is just a single speed Leslie here. I think, I've never actually used one of these before, but I think the control modes on this are just fast and stop. Because I think that this is this is the fast motor here. The slow motor will go down there and drive it through a rim drive type arrangement. But this has the same circuitry in it, or very similar as like the 122s, but it just doesn't have, it's got the same relay and everything, but I think how it goes is just fast and stop rather than fast and slow. Here's the maker's data plate. As far as I can tell, this is a 1962 model. It's got the Jensen woofer. This woofer looks a little different than the ones I'm used to. And the horn tweeter up in there. This thing is really dirty, and so it's going to have to get all cleaned out and re-lubricated. Here's the Leslie amp for the 22, It's really filthy and nasty looking. I'm gonna have to do lots of cleaning on this. It got new 6550 tubes put in 1985, and these were made at the General Electric plant in Owensboro, Kentucky. You can see it's worn off a little bit there, but 188-5, 188 is the EIA code for GE, and 5 is the Owensboro plant. 1985, 17th week. And I've actually seen 1992 MPD 6550 tubes in a Leslie amp. And as far as I know, those were the last, or some of the last tubes ever made in the USA in the original factory. It was then, at that time, owned by MPD Incorporated, which I think still makes microwave tubes there. But they phased out glass tube production in 1992, and the 6550 was the last tube made there. You can see a lot of nicotine and tar on the, I think that's the OC3, or the whatever the voltage regulator tube is called there, and a lot of nicotine and tar on this capacitor. This is an electrolytic, and you can buy brand new replacements for this. At least I think this is, unless this one's different. I'll just have to double check, but at least on the later ones it just plugs in. You can get brand new electrolytics from CE Manufacturing, which plug right into it. Yeah, it's got a socket on it, so it must just be kind of sticky in there. Some of them have a clamp that you have to remove, and it's got old paper capacitors in there, so we'll have to remove those. Here's the relay. And I'm trying to look and see what the functions of the relay are. As far as I can tell, it's just on and fast and stop. Got an electrolytic there. Got some really early diodes here. We may go ahead and replace these with 1N4007 diodes. These are very old diodes, and old 1960s diodes can be prone to shorting. And here's the schematic. Let me see if I can get a better look at this here. Yeah, it looks like the relay circuit is just either stop or fast. This circuit is very similar. Here's the circuit of the little box that would have come from the B2 guys. This one here. See, it's just an isolation transformer going into the Hammond output. And then you've got some capacitors in there. I think the capacitor in there might actually be a 250 volt. We may go ahead and upgrade the cap in there to 450 volts like this one has, just for extra protection, because I think these resistors divide that voltage down somewhat in order to go to the, and then here are the adapters. Looks like they've got a 33K resistor in there, so I'll go ahead and put that in as well, just to make sure it's authentic with what the schematic would have. And that voltage regulator is an OC3 tube. So here's one of the next projects we'll be working on. Make sure that this is on here tight and get this cleaned up and get new capacitors in it. Then we'll finish up the work on here. We may double check the capacitor in here, check the voltage on it, and then I'll go ahead and put that 33, if it was a 33K resistor, I'll verify that and put that in the circuit so that it's exactly what Leslie would have originally specified. So I'll try and do an update soon on the B2 when we make some more progress on the Leslie system.